Okay, so just continuing on with our geometric sequences, find the number of terms in this sequence. Okay, so in order to do that, you'd need to find your Tn and put it equal to 1 over 27, because that'll tell us, is it the 10th term, is it the 12th term, okay? So, first of all, we know A is 81 and R is our common ratio, and we get that by doing T2 over T1, okay? So 27 over 81. Okay, which is a third. Then we go for our Tn formula. So that's A or to the power of n minus 1. So 81 by a third to the power of n minus 1. Okay, and we want to know what term number is 1 over 27, so put that equal to 1 over 27. Now, 81, 1 to the power of anything is always just 1. Okay, so that's 81 by 1 over 3 to the power of n minus 1 equals 1 over 27. Okay, that power is outside the bracket, so it goes to the top and the bottom. 1 to the power of anything is always just 1. So what I actually end up with is 81 over 3 to the power of n minus 1 equals 1 over 27. Now I'm trying to find n, and n is a power. So let's bring that n up to the top of the line. Okay, so let's cross multiply and rearrange a few things. So that's going to come up there, and that 27 then is going to come up there as well. So I'm going to get 81 by 27 equals 3 to the power of n minus 1. Now, I didn't do anything to the power because I'm actually just cross multiplying. Okay, it's not like I brought it up above the line and made it a minus. I didn't do that. It's not on the same side. It cross multiplied. Okay, so 81 by 27 is 2187 equals 3 to the power of n minus 1. Can you remember, out of everything we've done this year, how would I get a power?
Log.
Lovely, logs, exactly. Okay, so log to the base 3 of 2187 will give me n minus 1. Okay, throw that into your calculator. Log to base 3, 2187 is 7. So 7 is n minus 1. So n is 8. So the number of terms in the geometric sequence is 8. So don't forget, if ever you're looking for a power, you're going for logs. Okay, and just one more example. Any issues with that? Great. Can I get rid of the board? Okay.
Yep.
Thank you. Okay, a ball is dropped from a height of 27 meters and loses 2/3 of its height on each bounce. Find the height of the ball on each of its first 4 bounces. So if we just think about it like that, okay? It's dropped 27 and it loses 2/3 of its height. So that means how much of its height does it come back up? It loses 2/3. A third, yeah, exactly. Okay, so this bounce is a third of 27. Okay, which is 9. This bounce then would be a third of 9. Okay, does that make sense? Find the height of the ball on each of its first 4 bounces. So that would be 27 by a third, 9 by a third, 3 by a third, and then 1 by a third. So that's its height on each of its first 4 bounces. And so on. Hence write down the height of the ball after the 10th bounce. Now, I'm going to do this 2 ways, okay? And you can decide which way you want to do it. If we're going to keep doing it this way, okay? I started with 27 and I got a third of it for the first bounce. So it was by a third to the power of 1 for the first bounce. Okay? Now, I had to then multiply by a third again to get the second bounce. So it was a third squared. I multiplied by a third again for the third bounce. So basically, that would be a formula for getting the height on each bounce. So it would be 27 by a third to the power of 10 if I'm interested in 10 bounces. Now, I personally like using a formula that I've been given, okay? So this one I had to come up with it myself, but if we think about, I'm interested in the height of the ball after the 10th bounce. If we think of it as a pattern of numbers and we're only interested in the bounces, my pattern of numbers goes like this: 9, 3, 1, a third, and so on. Okay? Like if I'm only interested in the height of the bounces, so that 27 isn't a bounce, so I'm not interested in that. Okay? Now, if I look at this, this is a geometric series. My A is 9 and my R is 3 over 9, which is a third. Now I can use my formula A R to the power of n minus 1. So T10 would be 9 by a third to the power of 10 minus 1. And when I throw that into my calculator, I get the same answer, 0.000457, which is 46. So it's up to you, okay? The difference in both of these is these I'm only interested in the pattern of numbers of the bounces, okay? It's only the bounces, and I'm interested in the 10th bounce, so that's why I can use this. Here, you have to think about what happens each time. It's exponential, it's more functions. This is more patterns, this is more functions. You get the same answer both ways. Janie, you okay?
Yeah, when I type it into my calculator, I get like the by 10
To the,
power.
yeah. Okay, so what that means is 10 to the power minus 4 is there's 0, 0, 0, and then the 4. Okay, that's what to the power minus 4 means. You've got 3 zeros and then the 4. So 0.000 and then a 4. Okay, we haven't done it yet. Well, you did it in junior cert, but that's standard notation. Okay, so if it was 10 to the power minus 5, it would be 4 zeros and then the 4. Alright? If you left your answer